Let us begin our class. I think you have gone through these materials and you could understand the concept of type 1 error and type 2 error. Let me ask to someone about this concept. അലീന എന്താണ് ടൈപ്പ് 1 എറർ എന്ന് പറഞ്ഞാൽ ടൈപ്പ് 1 എറർ അലീന
ഹലോ സർ.
എന്താണ് ടൈപ്പ് 1 എറർ എന്ന് പറഞ്ഞാൽ?
അതായത് നമ്മള് F0നെ റിജക്ട് ചെയ്യും. അതായത് F0 2 ആവുന്ന സമയത്ത് നമ്മൾ അതിനെ റിജക്ട് ചെയ്യും. അതിനെ ടൈപ്പ് 1 എറർ എന്ന് പറയും.
ഒരു ഉദാഹരണം പറഞ്ഞേ.
അതായത് സാറ് പറഞ്ഞ പോലെ ഒരാൾക്ക് കൊറോണ ആൾക്ക് നെഗറ്റീവ് ആയിരിക്കും. നെഗറ്റീവ് ഉള്ള ടെസ്റ്റില് കാണിക്കും, പക്ഷെ ശരിക്കും ആൾക്ക് ചിലപ്പോൾ പോസിറ്റീവ് ആയിരിക്കണം, പക്ഷെ നെഗറ്റീവ് ആയിരിക്കും ടെസ്റ്റിൽ കാണിക്കുക.
ഓക്കെ ഓക്കെ. അപ്പോൾ ആൾക്ക് കൊറോണ ഉണ്ടായിരുന്നു, പക്ഷെ ഇല്ലാന്ന് പറഞ്ഞ് റിജക്ട് ചെയ്തു അല്ലേ?
അതെ.
ഓക്കെ. റോസ്മിയ പറ, ടൈപ്പ് 2 എറർ എന്താ? റോസ്മിയ പറ, എന്താ ടൈപ്പ് 2 എറർ എന്ന് പറഞ്ഞാൽ എന്താണ് ടൈപ്പ് 2 എറർ? ടൈപ്പ് 2 എറർ എന്താണ്? എന്താണ്? ലിമ കെ ജെ
ഹലോ,
എന്താണ് ടൈപ്പ് 2 എറർ? എന്താണ് ടൈപ്പ് 2 എറർ? എന്താണ്?
അറിയില്ലേ?
ടൈപ്പ് 1 എറർ പറഞ്ഞല്ലോ. ടൈപ്പ് 2 എറർ എന്താണ്? കെസിയ പറ, കെസിയ ജോസ്.
ഹലോ സർ.
എന്താണ് ടൈപ്പ് 2 എറർ? ടൈപ്പ് 1 എറർ അലീന പറഞ്ഞു. ടൈപ്പ് 2 എറർ എന്ന് പറഞ്ഞാൽ എന്താണ്?
ഫോൾസ് ആയിട്ടുള്ളതിനെ ആക്സെപ്റ്റ് ചെയ്യുന്നത്.
അക്സെപ്റ്റിംഗ് എന്തായിരുന്നത്? ശരിക്കും അങ്ങനെ പറയാ ഫോർമാലായിട്ട്? അക്സെപ്റ്റിംഗ് H not പറഞ്ഞേ.
When it is false, accepting H not when it is false, call it type 2 error.
ഓക്കെ. ശരി. ഞാന് മനു പറയും, എന്താണ് ഒരു പവർ എന്ന് പറഞ്ഞ എന്താണ്? പവർ ഫംഗ്ഷൻ.
ഹലോ സർ.
എന്താണ് പവർ
ഫംഗ്ഷൻ എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ നമ്മുടെ പ്രോബിലിറ്റി ഓഫ് ടൈപ്പ് 1 എറർ ആൻഡ് പ്രോബിലിറ്റി ഓഫ് ടൈപ്പ് 2 എറർ മിനിമൈസ് ചെയ്തിട്ട് പ്രോബിലിറ്റി ഓഫ് 1 മൈനസ് പ്രോബിലിറ്റി ഓഫ് ടൈപ്പ് 2 എററിനെ മാക്സിമൈസ് ചെയ്യുന്നതിനാണ് പവർ ഫംഗ്ഷൻ എന്ന് പറയുന്നത് സർ.
അല്ല, അത് ആ പവർ ഫംഗ്ഷൻ എന്ന് പറഞ്ഞാൽ 1 മൈനസ് പ്രോബിലിറ്റി ഓഫ് ടൈപ്പ് 2 എറർ അല്ലേ?
ടൈപ്പ് 2 എറർ സർ.
അപ്പം നമ്മൾ എന്താണ് ടെസ്റ്റിംഗിൽ ചെയ്യുന്നത്? അപ്പോൾ പ്രോബിലിറ്റി ഓഫ് 2 എറർ ഉണ്ട്. ആ 2 എററിൽ 2 എററും മിനിമൈസ് ചെയ്യാൻ
മിനിമൈസ് ചെയ്തിട്ട് ആ ഫംഗ്ഷനെ മാക്സിമൈസ് ചെയ്യും.
അത് ഓട്ടോമാറ്റിക്കലി ടൈപ്പ് 2 എറർ മിനിമൈസ് ഓട്ടോമാറ്റിക്കലി 1 മൈനസ് ടൈപ്പ് 2 എറർ എന്ന് പറഞ്ഞാൽ മാക്സിമൈസ് ചെയ്യും അല്ലേ?
ആൽഫ എന്ന് പറഞ്ഞൊരു ആൽഫേനെ 0.001 മൈന്യൂട്ട് ആയിട്ടുള്ള ഒരു പോയിന്റിലേക്ക് കൺവേർട്ട് ചെയ്തിട്ട്
കുറച്ച് വെക്കും അല്ലേ? മിനിമൈസ് ചെയ്യും, ബൗണ്ടറി വെക്കും. പരമാവധി ടൈപ്പ് 1 എറർ 0.01 അല്ലെങ്കിൽ 0.05 ഒക്കെ വരാൻ പാടുള്ളൂ എന്ന് നമ്മൾ നിശ്ചയിക്കും അല്ലേ? അത് കഴിഞ്ഞിട്ട് 1 മൈനസ് ടൈപ്പ് 2 എറർ മാക്സിമൈസ് ചെയ്യും, അതായത്
മാക്സിമൈസ് ചെയ്യും.
ഓക്കെ. So we have discussed up to that, and some of you have explained correctly, and some students says that they don't know. They have to listen carefully and they have to read and try to understand. Don't say, I don't know. That is your duty, because we have discussed, I have given the video and everything. If you have any doubt, you can listen again and again. That is the criteria, or that is the possibility. Then also you are saying that, some of you are saying that, I don't know. That means you are not seeing or not listening the video. Okay. You should respond at least minimum, whatever be the information you have received, you have to respond. Don't say, I don't know. Okay. It is better to listen the video again and again if you don't know the concept. ഞാൻ ക്ലാസ്സിലാണല്ലോ, പിന്നെ വിളിക്കാം കേട്ടോ. So let us discuss two examples, very wonderful examples, good examples. You can get all the information, the methodology of testing of hypothesis using these two examples. One example for non-randomized test and another example is for randomized test. You should understand, you should try to understand how to do this type of problems. Only two problems are given here. You can study the procedure of conducting testing of hypothesis, or procedure of finding out probability of type 1 error, probability of type 2 error, power, etc. Okay. So listen for this example. Let x1, x2, xn be IAD n mu comma 1 random variables, where mu is a unknown, but it is known that mu belongs to theta. What is a theta? Theta is nothing but set mu naught comma mu 1. Set mu naught comma mu 1. And we are considering that mu naught is less than mu 1. Okay. So there are only 2 points in the parametric space. What are the points? Mu naught and mu 1. And apart from that, mu naught is less than, is a smaller quantity than mu 1. So which value will be selected for the distribution? So that is our problem. So we have to test. So we will put two hypotheses. One hypothesis based on mu naught and other hypothesis based on mu 1. So which hypothesis is true? Okay. So null hypothesis h0 xi follows n mu naught comma 1, and h1 xi follows n mu 1 comma 1. Here it is a normal random variable. N mu naught comma 1 means x follows a normal random variable. Okay. And in alternative hypothesis, we are assuming that x follows n mu 1 comma 1. For example, you are considering your height or your mark in statistics. You are claiming that the mark distribution is n mu what is the average mark? Suppose it is 40, n 40 comma 1, and some other option is there, that is x follows, mark follows, and 45 comma 1. So which is true? Okay, we have to test that. So both h0 and h1 are simple hypotheses. What is the reason of saying simple? Yeah, there are only 1 point for the testing. Okay, here we have only 1 point for the testing. So both h0 and h1 are simple hypotheses. Intuitively, one would accept h0 if the sample x bar is closer to mu naught than close to mu 1. So some of you claim that your average mark is 40, and some other group claims that your average mark is 45. So how can we justify that claims? You can take a sample, and if the sample mean is close to 40, then we can say that 40 is the population mean. If the sample mean is close to 45, we can say that 45 is the population mean. So based on this sample mean, we can say that mu naught or mu correct. Okay, so our aim is to yeah, so if x bar is closer to mu naught than mu1, then one would reject h naught if what is the that is what is h naught? What is h naught? H naught is x follows mu naught comma 1. So if x bar is much deviated from mu naught, then we can say that alternative hypothesis is correct. So instead of, we can say that one would reject h naught if x bar is greater than some k. Okay, it is much larger than mu naught. Instead of x bar is closer to mu naught, it is much deviated from mu naught. So instead of, we can say that h naught would be rejected if x bar is greater than k. Okay, and except otherwise, if it is less than k or it is very close, we can accept the null hypothesis. So that will be the that may be the good criteria for the selection of mu naught compared to mu1. So the constant k is determined from the level of recurrence. You know that we are restricting type 1 error to some alpha, and 1 minus power is some 1 minus probability of type 2 error. So based on that restrictions, we can find out the value of k. So suppose under null hypothesis xi follows n mu naught comma 1. So you know that if x follows n mu comma 1, then x bar follows n mu comma 1 by n. That means if x follows n mu comma sigma square, x bar follows n mu comma sigma square by n. So here sigma square value is 1 by n. Okay, so under null hypothesis, x bar follows n mu naught comma 1 by n. Similarly, under alternative hypothesis, we can say that x bar follows n mu1 comma 1 by n. Okay, because we have assumed that under alternative hypothesis xi comma 1. So from that we will get x bar follows. Here we have taken distribution of x. Then automatically distribution of x bar will be n mu1 comma 1 by n. Okay, so we obtained the distribution of x bar under null hypothesis and distribution of x bar under alternative hypothesis. So we will use that information for computation of probability of type 1 error and computation of power. Okay, we will use this information for computation of probability of type 1 error, and we will use this information for the computation of power. Okay, so this is actually the rejection criteria. We will reject the null hypothesis if x bar is greater than k. So we can we can say that this is equivalent to rejecting h naught. Rejecting h naught. Instead of rejecting h naught, we will write probability of x bar greater than k, because this is the rejection criteria. Because here we have said that one would reject h naught if x bar greater than k. So reject h naught means x bar greater than k. When x bar greater than k, we will reject the null hypothesis. So under null hypothesis, rejecting the null hypothesis. So that is the probability of type 1 error. So we can compute this one. How can we compute this probabilities? Yeah, we can compute that probability using the methodology. I will write in the word format. Probably you can understand the techniques of computation of this alpha. So actually we are subtracting mu naught both sides, x bar minus mu naught greater than k minus mu naught, and after that we are dividing with 1 by root 10 on both sides. So we will get the result. Okay, so I will show you. Is that? So probability of x bar greater than k. Probability under null H naught under null hypothesis. Probability of rejecting H naught when H naught is true, that is exactly equal to probability of x bar greater than k under H naught, that equal to probability of, what is that, x bar minus mu naught. Under null hypothesis it is mu naught. Yes, mu. Yeah, mu naught greater than k minus mu naught. Mu naught. Okay, this is equivalent to, what is that, probability of, let us divide this one with respect to the standard deviation. What is the standard deviation? 1 by square root of n. Okay, again right side you can divide the right side also. 1 by square root of n. So this is the this is actually probability of type 1 error. So that what is the value of probability of type 1 error? That is we are restricting to alpha. Okay, so we obtain an equation, probability of rejecting H naught under H naught equal to probability of x bar greater than k under H naught, that equal to probability of x bar minus, here we have x bar here we have here we can use x bar, here also we can use x bar. So this is actually what is that, this we can copy this one. This one is actually this is some standard normal variable. Okay, let us put z for the for x bar minus mu naught by 1 by root. So that is some standard normal. After standardization, what is the method of standardization? We can subtract the mean and divide with the standard deviation. That is the standardization method. So this is standard normal variable greater than k minus mu naught divided by root n. Okay, so this will be, so what is the curve of standard normal curve? You know what is standard normal curve? Standard normal curve is a bell shaped curve. Okay, so what is the probability of, so this is exactly the probability of Z greater than, this can be called as some Z naught, small z can be represented as some Z naught. Okay. So Z greater than some Z naught, that equal to alpha. So what is the region? Let's look at here. Let us look at this figure. So the Z, this is the 95% region. So if we consider one side, let us consider this one. This one is the point corresponding to alpha equal to 0.05. So if you, in particular, if you take alpha equal to so if we consider alpha equal to 0.0105, so Z naught value will be, from the figure we can see that this is 1.725. This is T value. It is T. Okay, no problem. T is almost this is previous. Set test. This one. The critical area. Okay, the 5% standard normal critical area is 1.65. So if we are taking 0.05 for alpha, what will be the value of Z naught? 1.65. Okay, 1.65, and from this we can find out the value of K. How can we find out the value of K? Just substitute here. We can move to this side. What happens? Yeah, this will become root 10 here. Root 10 will appear here. Root 10, and the root 10 will disappear from here. Okay, mu naught will come to the right side. Mu naught will come to the right side. Let us take this as plus mu naught plus. Okay. So what is K? K is equal to mu naught. We know mu naught value. Sometimes it may be 40 or 50. Whatever be the assumption we have used, that will be used there. In that case, we can say that K is equal to some 40. For example, we are considering our mark in statistics, that is average mark in statistics 40, Under null hypothesis you are claiming that if you are claiming that it is 40, you can put the value of 40 and you can put the value of number. If you are taking a sample of size 25 your class, then we can put the value of 25. So this will result in a numerical value. What will be the numerical value? What will be numerical value? 40 plus 1.65 by 5. 1.65 by 5. What is the value? 1.65 by 5. 0.33. Okay. 0.33. So what is the value? 40.33. So what will be the criteria? Yeah, we can reject your assumption when x bar, if you take another sample and if the x bar shows x bar is greater than 40.33, you can reject the null hypothesis. So alternatively you can accept the alternative hypothesis. So this is the application of this testing of hypothesis. So we can find out the region of rejection. Okay. So yeah, it is mentioned here. K is nothing but this one. We have applied all these things. No problem. Now, so that what will be the test function? We have rejected when x bar is greater than k. What is k? K is mu naught plus z alpha by root n. So our criteria is we have to reject x bar if greater than k. Okay. So the test function would be 1 equal to 1 if x bar is greater than mu naught plus z alpha by root n, and 0 otherwise. So here x bar is known as test statistic and phi is non-randomized test. Okay, with the critical region. Critical region is this one. What is critical region? C equal to x such that set of all x values such that x bar is greater than mu naught plus z alpha by root n. And note that in this case continuity of x allows us to achieve. Okay, add this. Now you compute power of the test. Power is taken based on alternative hypothesis. So we have to use mu1. Under mu1, what is power? We can write like this. Similarly, we can write this. Write like this. What will be the power? What is power? Probability of rejecting H naught when H1 is true. Okay, probability of rejecting H naught when H1 is true. So we have to replace with the mu1. So this is actually 1 minus probability of type 2 error. Type 2 error. We can remove this term. This is the step. We can see that this is the step they have used. Oh, sorry, 1 minute. This is the we have to put k first here. What is the k value? K. What is k? K is exactly, what is k? K is mu naught plus z alpha by root n. So we have to put the z alpha. Paste. Okay. Let us keep this as such. alpha. So we can put this value here. Use this numerical value, that's a special case. So what is the result? Actually this can be written again this is equal to we can mu naught minus mu 1 plus mu naught minus mu 1 into root 10 into root 10 divided by let us put this root 10 to the numerator. So what will be the step? Okay, as a next step we can do that. Step here we see here. Okay, instead of writing this, so for the step we can write give Z alpha here, and then put a minus sign, so automatically this okay, this is the power function, probability of Z greater than Z alpha into mu 1 minus root n into mu 1 minus mu 0. Okay, so that is power function, probability of time. You know that from power function we can say that, so this is power. Okay, power is exactly equal to 1 minus probability of type 2 error. So from this we can say that what is probability of type 2 error? What is probability of type 2 error? Just move this term to right side and this term to left side. Well, just let's put here for the safety. So this is the probability of type 2 error. From this equation we can obtain probability of type 2 error. So that is mentioned here. Okay, probability of type 2 error 1 minus this one. So what is 1 minus probability of A? That is probability of A complement. So that will be, so that can be written as like this. Probability of 1 minus probability of A equal to probability of A complement. Less than or equal to. Okay. This is the probability of type 2. So we have obtained probability of type 1 error, power, and probability of type 2 error. So that are the parameters we have to determine in a testing of hypothesis problem. Probability of type 1 error, probability of type 2 error, or power, and probability of type 2 error. This is the methodology we have used. So you can write this problem today and submit back to me through Moodle. Okay, I will send these steps to you. Problem using WhatsApp group, and you can use for writing the steps. And if you have any doubt, you can ask to me, and you should read and listen this listen again and again to understand the concept. Okay, so hard work is required for understanding this concept. You should not spend time with laziness. Okay, you have to read and read again and try to understand the concept. Okay, let me take the